Hi, my name is Sarah Wietske. I'm a senior application scientist here at CCG. Today, I'd like to introduce Biologics high-throughput virtual screening. This is useful when you want to screen many proteins against a target to see if they're potential binding partners. It can be used for different modalities such as antibodies, DNA, RNA, peptides, and so on. It's an ultra-fast alternative to protein-protein docking. So let's get started. We're starting with an antibody-antigen complex that has been prepared using QuickPrep. I've also annotated the antibody, which creates these so-called sets or collections of atoms, such that they can be easily referenced in the various Mo applications. Furthermore, I've colored the antigen in gold. All right, so I'm ready to create a pharmacophore, but before I do so, I'm going to instruct Mo to interpret the antibody itself as a ligand. I'll just go here and choose ligand like this. All right, let's go ahead and look at contacts. I'll go protein and contacts. So this is the protein contacts panel. It's split into 3 sections. Up at the top, I have my 2 pairs of C interactions between. In the center, I'll get a list of my contacts, and down at the bottom, I can filter them. It's already recognized I have an antibody and antigen, but I'll actually go ahead and really zoom in here on the CDRs. As I press search, I get a list of contacts. They are given a type, so H for hydrogen bond, I for ionic or soul bridge, and that refers down to the types here. You can see we also have covalent, arene, and metal, and there's also distance. Distance, there's generally a lot, and they're a bit weaker, so we hide them by default. Now, the way we read this is I have a hydrogen bond where on the heavy chain, I have a threonine 30 interacting with, on my antigen, a glutamate 73 with this energy and distance, and it's a side chain interaction. Now, I'm interested in the interactions that the antibody displays, and I can see there's multiple of the residues here that have multiple contacts. So I'm going to use the aggregation. This way, I just see one entry in the panel here per residue in the antibody. I'm also going to sort this by energy, so I have the strongest, the most important ones at the top. Let's start here. So heavy chain, aspartate 99, interacting with antigen, lysine 97, and asparagine 77 very strongly. I have an aspartate 32 also on the heavy chain, interacting with the same 2 residues on the epitope. And finally, I have another quite strong bond here, so minus 11 or 12-ish. That's a light chain, asparagine 32 with a glycine 16 and lysine 96. So those are very strong and clearly very important for the binding mode. We're going to take a closer look at them in Mo. So let me move my panel here. I'm going to isolate and press center, so Mo will zoom in and display them. I'm also going to add a label so we can see which is which. So up at the top, I have my asparagine, making my hydrogen bonds to the glycine and the lysine. And below, I have my 2 aspartates interacting with the lysine and the asparagine 77. Now, what I want to do in my pharmacophore is I want to encode that I will have partners here that can make those interactions. I'm not going to say which residue they should be, but just which features they should have to make similar interactions. So let's go ahead and open the Pharmacophore editor. Here we are. As soon as you open the Pharmacophore editor, you get these colored dots. We call them annotation points. Think of them as a help to you from Mo. So what Mo is saying here is that as an important atom or group of atoms you might want to make a feature out of. And it's up to you to choose those that you actually want to include in your Pharmacophore. The Pharmacophore editor itself has 3 sections. Up at the top, we have options for the annotation points. In the center, we'll build up a list of features, and down at the bottom, we can edit them and create partial matches. So let me move my panel a bit to the side here. I think I will arrange myself a little bit here, and I'll add a label to the annotation point. Now it's up to me to go and choose the ones that encode my binding mode. So that will include having a donor here, an acceptor here, and I'll make a feature of those. Then I'll go down to my 2 aspartates, and here I will make the features for the carboxylic acid. I'll select those 2 here and make features of these. So now my features represent what I saw in my protein contacts panel. Let's tidy up a little bit. I'll hide the annotation points, and I will close the contacts panel as well. Now think of a pharmacophore as an iterative process. This is a starting point, but I actually want to modify each of these features. So you can, for instance, use Booleans, or you could use smarches, or you can change the size of them. I'm going to be more lenient. Let's change the size of all of them in one go, make them bigger here. That means we are more lenient, more things can match. There's a bit more 3D space to move around on here. Now, the other thing I want to encode is I want to make sure when I come along with other antibodies, I want to make sure none of them clash with my antigen. So I'm going to select my antigen, and I'm going to make a volume that's called excluded. This is a no-go zone. No antibody atoms are allowed to go in here because then it would clash with my antigen. Let me just hide that here and deselect my atoms. All right, I'm going to press search to get the Pharmacophore search panel. Again, it has 3 sections and you always start at the top. The top is for giving the database to search. In the center, the Pharmacophore you want to search it with, and down at the bottom, there's settings for the output. I'm going to browse and find a database that holds a lot of antibodies. Specifically, I'll use our antibody.mdb database, which has more than 16,000 public structures from when this version of Mo was created. I'm going to search this database with the Pharmacophore I have in my query editor, but I want to use a selection. So the database holds both antibodies and antigens, but I don't want to search the antigen. I only want to search the antibody. So I can specify that. I can even go further and say, out of the antibody, just search the CDRs for me. That will save me time. Let's go ahead and press search. You get a progress bar. This bar shows you how far you are, and you can see how it goes through hundreds of molecules in a matter of seconds rather than hours. And there's already some hits. I would suggest as soon as you have hits, take a look at them. So I'm going to move my panel a bit to the side here, and then I'll use the database view icon to pop up the results. So the hits are displayed in a database viewer, a lot like an Excel spreadsheet, rows and columns of numbers, but you can see that these are actually my hit molecules. It's also the main entry points for calculating protein properties, making QSPR models, and also any sort of data visualization and analysis. Now, when you get your hits, have a look at them with File and Browse. What I'll do is I'll just tidy up, hide my atoms, toggle on my ribbons, and color them by chain. Now, what you're looking for is how do they match your expectation? So, of course, they will all match the pharmacophoric features. But as you look at it, you can see some of them are matching slightly different than maybe something like this, right? So maybe that tells you that your features were a bit too lenient. They can match an antibody not exactly on the CDRs as we had anticipated. So we'll just go back and change that. I'll close the database here, stop the search, go back up and say maybe that was a bit too lenient. Let's go maybe completely in the other direction. I'll make it very small here instead. 0.5. Now they're really, really strict. Let me zoom in so you can really see the small features here. I'll go back to the search. I'll restart the search. Let's just override the original one. And you see how much faster it goes now because it's a much more restrictive search. It has, really strict requirements. So I'll get fewer hits out, but I will also get more relevant hits out. Let's take a look while they're coming in here. I'll browse, do the same thing, hide the atoms, toggle on my ribbons, do the chain coloring. And now as I go through them, you'll see how other antibodies can match the same epitope of the antigen in the same way, right? So we get a lot of different antibodies that can match here. Now, what you also see is how they actually are docked. They're all in the complex. So you can now take these, refine them, and score them, and you'll have the same as a docked complex. So I hope I've shown you now how you can use the protein contacts panel to identify key interactions, encode them in a pharmacophore, and use this to search through other databases, peptides, nucleic acids, or proteins, or whatever you're interested in here. And you can run through it as a really, really fast filtering and also end up with poses that you can continue with and get doc poses from. If you have any questions, please reach out to me at support@chemcom.com.